In episode 98, titled Firewall Types, NGFW versus Cloud Native Firewall versus WAF, the goal is to treat firewall choice as matching the control to the traffic layer, because the wrong control at the wrong layer creates gaps, duplicated effort, and confusing operations. Firewalls are not interchangeable simply because they all block traffic, and the exam often tests whether you can align capabilities to what you are protecting, where the traffic flows, and what kind of inspection is needed. A useful way to think about this is that network controls protect paths and segments, while application layer controls protect specific protocols and behaviors that live above the network layer. When you pick the correct control for the layer, policy becomes clearer, monitoring becomes simpler, and incident response becomes faster because each tool has a defined job. That clarity is what turns a security stack into a security system rather than a collection of overlapping products. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A next-generation firewall, commonly called an NGFW after first mention, is designed to inspect beyond basic ports and addresses and to enforce policy based on applications and users with deeper inspection features. Traditional firewalls primarily evaluate network and transport layer attributes, while next-generation firewalls can identify application protocols, apply user-aware rules, and sometimes inspect encrypted traffic in controlled contexts. These capabilities support more expressive policy, such as allowing a business application while blocking risky subfunctions, or applying different rules based on authenticated identity. Next-generation firewalls also often include threat prevention features like intrusion detection and intrusion prevention, malware inspection, and reputation-based filtering, which makes them useful at choke points where many flows can be observed. The exam tends to emphasize that next-generation firewalls are broader controls that can serve segmentation, egress control, and advanced inspection needs across many protocols. When deployed thoughtfully, they function as multi-purpose enforcement points. But that flexibility also means they require careful governance to avoid becoming a policy dumping ground. A cloud-native firewall integrates with the provider network and identity model, and its advantage is that it aligns naturally with cloud constructs like virtual networks, security groups, routing tables, and identity-based access. Cloud-native controls can often enforce policy at cloud ingress and egress points, and can tie rules to cloud resources and tags rather than only to static addresses. Integration matters because cloud environments change quickly, and policies that can reference resource identities, workloads, or labels reduce the brittleness that comes from hard-coded addresses. Cloud-native firewalls also commonly integrate with cloud logging and monitoring pipelines, which supports faster correlation between network events and cloud resource context. The exam framing usually expects you to recognize that cloud-native firewalls are designed to scale with cloud architecture and to support consistent enforcement across cloud networks without requiring appliance-style management for every segment. When used correctly, they reduce operational friction while still providing strong network-level controls. A web application firewall, commonly called a WAF after first mention, protects web applications using hypertext transfer protocol awareness and rules that understand web request structure rather than only network flows. The Web Application Firewall operates at the application layer, inspecting requests and responses for patterns that indicate common web attacks, such as injection attempts, protocol abuse, and malicious request sequences. It can enforce rules based on uniform resource identifiers, headers, cookies, parameters, and payload behaviors, which makes it suited to protecting web endpoints that are exposed publicly. The exam often emphasizes that web application firewalls are specialized tools, not general network segmentation controls, because they focus on hypertext transfer protocol semantics and application threats. Web application firewalls also commonly include features like rate limiting, bot mitigation, and virtual patching for known web vulnerabilities, which can buy time when application fixes are pending. When you view the Web Application Firewall as an application safety layer rather than a network boundary, its placement and purpose become much clearer. Choosing a Web Application Firewall for web request threats is the right move when the problem you are trying to solve lives in the request itself, such as malicious input, abusive request patterns, or attempts to exploit application behavior. Application-level controls matter because attackers target what the application does, not only whether a port is open, and a web application firewall is built to understand and filter those behaviors. A web application firewall is also useful for adding protections quickly without changing application code, which helps when teams need immediate risk reduction while longer-term fixes are implemented. The exam expects you to recognize that this does not replace secure development, but it does add a protective layer at the right place in the flow, which is at the web ingress point where requests first arrive. When you choose a web application firewall, you are choosing to inspect and control hypertext transfer protocol interactions, which is a different control objective than simply segmenting networks. This is why the Web Application Firewall is the natural choice for web request threats and application-level enforcement. Choosing a next-generation firewall for broad segmentation and advanced inspection needs is usually appropriate when you need to control many protocol types, enforce segmentation boundaries, and apply deep inspection capabilities beyond basic allow and deny rules. Segmentation often requires enforcing rules between user networks, server networks, management networks, and partner networks, and a next-generation firewall can serve as the choke point that applies those boundaries consistently. Advanced inspection needs might include identifying applications, applying user-aware policy, detecting known exploit signatures, and controlling egress destinations, all of which are common requirements in hybrid networks. The exam often frames next-generation firewalls as the versatile enforcement layer that can sit at perimeters and internal boundaries, complementing more specialized controls like web application firewalls. The key is that next-generation firewalls are not only about inbound protection, but also about controlling east-west and outbound flows where attackers often move after an initial compromise. When you choose a next-generation firewall, you are choosing a multi-protocol enforcement and inspection platform that supports segmentation and broad policy. Placement is where these choices become operational reality, because the same tool can behave very differently depending on whether it sits at a perimeter, between internal zones, or at a cloud ingress point. Perimeter placement focuses on traffic entering and leaving the environment, often emphasizing egress control, inbound exposure reduction, and integration with upstream protections. Internal segmentation placement focuses on limiting lateral movement, isolating sensitive systems, and creating boundaries where monitoring and policy enforcement can detect and block post-compromise activity. Cloud ingress points are where cloud-native firewalls and web application firewalls often live, enforcing policy close to exposed resources and integrating with cloud routing and identity constructs. The exam tends to test that you understand the difference between north-south traffic and east-west traffic, and that placement decisions should reflect the threats you're trying to reduce. When placement is intentional, you avoid both blind spots and unnecessary complexity, because each control sits where it can see the traffic it is meant to govern. A scenario makes this tangible, so consider protecting a public web application that is exposed to the Internet and must resist both web-based attacks and broader network threats. A web application firewall can be placed in front of the application to inspect hypertext transfer protocol requests, block injection attempts, enforce request rate limits, and filter suspicious patterns that target application behavior. Behind that, a gateway or firewall layer can enforce network segmentation, ensuring the web tier can only reach required internal services and that management access paths remain restricted and monitored. This layered placement means the web application firewall handles web request threats at the application layer, while the network firewall layer handles segmentation and broader protocol control, preventing a web compromise from becoming unrestricted internal movement. The exam often rewards this layered approach because it shows you understand that web protection and network segmentation solve different problems and should be combined rather than conflated. When you design it this way, the public web app is protected both against direct web exploitation and against the post-exploitation pathways that attackers rely on. A common pitfall is using a web application firewall as a replacement for network segmentation because it leads to a false sense of security and leaves lateral movement pathways ungoverned. A web application firewall can block many web attack patterns, but it does not automatically restrict what the application servers can reach on the internal network once a compromise occurs. If the internal network is flat and permissive, an attacker who finds a path through the application can pivot to databases, identity services, and management interfaces that the web application firewall was never designed to protect. The exam expects you to recognize that the web application firewall is a specialized control for hypertext transfer protocol interactions, not a general-purpose segmentation boundary for all traffic types. Treating it as segmentation can also create monitoring gaps because teams may assume internal movement is covered when it is not. When you keep segmentation separate and enforce it with appropriate firewalling, you prevent this pitfall and preserve a clearer defense-in-depth model. Another pitfall is duplicating policies across tools without governance, because overlapping controls can produce inconsistent enforcement and operational confusion. If the same allow and deny rules are copied into a cloud-native firewall, a next-generation firewall, and a web application firewall, drift becomes inevitable, and responders will not know which policy is actually controlling a given outcome. Overlap can also cause troubleshooting delays during incidents because a blocked request may be blocked by any one of several layers, and without clear responsibility boundaries, teams spend time arguing instead of resolving. The exam framing often pushes toward clear responsibility assignment, where each control has a defined purpose and policy scope, and where exceptions are documented and reviewed. Governance does not mean slowing down changes unnecessarily, but it does mean knowing where policy should live, how it is updated, and how it is validated. When governance is clear, duplication decreases, consistency improves, and security controls become easier to operate. Quick wins include defining responsibilities per control and avoiding overlap, because clarity is a low-cost improvement that prevents many long-term failures. Defining responsibilities means deciding what the web application firewall will handle, such as hypertext transfer protocol threat filtering and request rate controls, while the network firewall layer handles segmentation and protocol-level access between zones. It also means deciding what cloud-native firewall rules will handle at cloud ingress and egress, and how those rules align with broader network architecture and identity models. Avoiding overlap reduces the chance that controls fight each other, and it reduces the maintenance burden of keeping multiple policy sets consistent. The exam expects you to recognize that clear responsibility leads to better monitoring, because logs and alerts can be tied to specific enforcement points rather than being scattered across overlapping layers. When responsibilities are clear, teams can tune, test, and improve each layer independently while preserving a coherent overall defense. A memory anchor that fits this episode is web threats need WAF, networks need firewalls, because it captures the primary layer distinction in a way that is easy to recall under exam pressure. Web threats live in hypertext transfer protocol requests and application behavior, so the web application firewall is the right tool to inspect and enforce at that layer. Network segmentation and multi-protocol controls are network problems, so next-generation firewalls and cloud-native firewalls are the right tools to enforce boundaries and manage access between segments and to the Internet. This anchor also helps prevent the temptation to use one tool as a universal solution, which is a common exam trap. When you remember the layer, you remember the tool choice, and you also remember the placement, because web application firewalls sit at web ingress, while network firewalls sit at boundaries and choke points. With that anchor, selection becomes a reasoned mapping rather than guesswork. A useful exercise is choosing the firewall type for 3 traffic examples, because it trains you to map traffic layer to control layer. If the traffic is inbound hypertext transfer protocol to a public web application, the web application firewall is the appropriate choice because it can evaluate request structure and block application layer attacks. If the traffic is east-west movement between internal segments, such as user networks to database networks, a next-generation firewall or cloud-native firewall is appropriate because segmentation and protocol control are the goal. If the traffic is cloud egress from workloads to the Internet, a cloud-native firewall is often appropriate because it integrates with cloud routing, resource identity, and logging, enabling consistent egress policy without fragile address-based rules. These examples show that tool choice depends on what you need to inspect and enforce, not simply on whether the traffic is allowed or denied. Practicing this mapping builds the instinct the exam is testing. Episode 98 concludes with the idea that firewall selection is a layer matching exercise where you choose the control that best aligns to the traffic type, the inspection needs, and the placement in the architecture. Next-generation firewalls provide broad segmentation and deep policy features across many protocols. Cloud-native firewalls integrate with provider networks and identity to enforce cloud ingress and egress controls. And web application firewalls protect web apps through hypertext transfer protocol-aware rules. The pitfalls are predictable, where a web application firewall is misused as segmentation, and where duplicated policies across tools create drift and confusion. The placement walkthrough rehearsal is to take one service, trace its inbound and internal flows, and narrate where a web application firewall would sit, where network firewalls would enforce segmentation, and how cloud-native controls would align at cloud ingress points. When you can narrate that placement clearly, you demonstrate exam-ready understanding of what each firewall type does and how to use them together without overlap. With that clarity, firewalls become deliberate instruments of architecture rather than reactive patches applied after incidents. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.